Welcome again to the Southwest Climate Podcast. Mike Crimmins, how you doing?
Good, Zach. Good. It's over.
It's over, October. It's Friday, first Friday in October.
Yep.
The good thing about it being October and the monsoon being over and doing this podcast on a Friday is we don't have to be concerned about what we say on today being overwritten by a weekend storm. You
It's
know,
true.
in the monsoon, we don't get this out until Monday or Tuesday if we do it on a Friday, and a lot can change in the monsoon season.
Yeah, pretty short shelf life on anything we say.
Um, and I thought about it today. I think October is my second favorite month,
Oh, 100%.
climate wise.
What's your first?
July,
Oh, because of the beginning of monsoon?
because the beginning of the monsoon. Okay, so October, it's also my birthday month, but that's not why. Like
Oh,
the cool temperatures in the morning, like I just have more energy. Like I feel like I get my mountain legs back. Like there's
oh, me
spring
too.
in my steps.
Yeah.
My
Yeah.
muscles feel like I don't feel as old as I do normally, like in August. Like I feel really old in August.
Yeah, 100%. October is my favorite month here because of the release of that tension of the humidity and the long days and I think I've been just kind of traumatized by past couple of monsoons that July now is kind of like makes me a little twitchy. And so I don't like have it as like a regular like, oh yeah, it's gonna be awesome. It's more like, I don't know, guys, how's this gonna play out? October I know is gonna give me shorter days, lower humidity. Mosquitoes will eventually kick off. Like that kind of stuff it's transition towards the end of the month, man.
Cool mornings. I mean, the cool
Cool
mornings are
mornings,
amazing.
yeah. Yep. Yeah. Every day gets a little better. It's the only thing you can kind of count on anymore. Is at least the weather will get a little bit better every day here in the Southwest in October.
All right, so we can say goodbye to, we're going to say goodbye to the monsoon. We're going to do a recap of the monsoon. We have to talk about September, right? Because September was interesting to say the least.
Yeah, it was.
And then we'll sort of go over what's on the horizon.
Yep.
Sound good?
Yeah, I'm ready.
All right. So we've painted the big picture of the monsoon in the last couple of podcasts. It hasn't really changed. The story of the monsoon is that ridge, our friend the ridge, never really set up in a favorable position. Didn't stick around to our north. We basically, it wasn't so bad for New Mexico, I guess the position. It sort of allowed for incursions of more rain in New Mexico, which is largely seen in the percent of average maps that many of you listeners have probably looked at. But Arizona, it was pretty bad. So Mike, you have about 103 stations that you routinely pull data from. 32 of them showed above average rainfall, 71 were below average. So that gives sort of the story right there. The map itself is interesting, and I have mixed feelings about it, which when we talk about September, it's because there is actually a area right around Phoenix that all monsoon season was very dry, but now blinked on at the end of the month because of a few days worth of rain, and it looks above average. So that's like one of a few places that are above average in Arizona. The other one is in southwest part of the state around Yuma. Yuma doesn't get a lot of rain. Much of that came in one event. So looking at a sort of above average is a little bit misleading for that area of the state that just doesn't experience a lot of rainfall. And then the other part is northwest with the border of Nevada, sort of northwest of Kingman area. Everything else is either right around average or much below average. And then you move out to New Mexico, and much of New Mexico is actually near or above average. Um, right around Roswell, Las Cruces, Deming, El Paso, all of those areas sort of were where more moisture fell, even all the way up in this to Santa Fe. So maybe the sort of eastern two-thirds of the state is really where the rainfall happened across the Southwest this monsoon season. One thing, Mike, before I turn it over to you, in terms of ranks, so between June 15th and the end of September, Tucson came in, the airports, these are all at the airports in the major cities, came in at the seventh driest out of 76. So from 1950 on, I pulled data for the airports. Tucson's the seventh driest. Phoenix is actually the 46th driest, which is actually the 30th wettest. So it's wetter than average. But again, we'll talk about this when we talk about September. Flagstaff 14th driest, Albuquerque 15th driest, and El Paso was 45th driest, or what would that be? That would be the 31st wettest. So El Paso and Phoenix were above average. Every other Tucson, Flagstaff, and Albuquerque were much below average. So, Mike, did this year remind you of anything? Any other year? Monsoon season.
Yeah, it actually. So are you saying, okay, there's a couple ways different ways to think about it. The September really colored how I think about this year, right?
Yeah.
And so you and I were pretty bummed last time we talked. Especially having August be so quiet and so dry across most of the Southwest except for New Mexico, which really did have a completely different monsoon. That made the kind of the analog year comparisons really complicated because I think we wanted to be as miserable or feel like we had shared some misery with summer 2020, but summer 2020 was bad everywhere. Arizona, New Mexico, very bad. And even up to that point, we were still a little bit wetter than we were with 2020. And the Southwest getting broken up between East and West. Arizona was suffering some similar summers. It actually reminded me of last summer, quite honestly, as we were heading into the beginning of September. And that actually completely colored my monsoon fantasy forecasts, which were really, really good up until probably the second week of September, when I crossed into top 10 territory, unheard of in my.
It was impressive.
Well, I was impressed.
But you were pessimistic for September.
Yeah, I mean, I
Of
honestly
course, I was too.
yeah, so that was the weird thing about it, was that the persistence forecast often kind of works, but there was a subtle shift in the weather pattern, which we can talk about, but I'll first talk about my analog year. Is what it reminded me of was 2011. And we actually have to go back 14 years. And the reason I remember this is it was a very similar summer here in Tucson, a very mediocre monsoon, suffered through not much activity in through July, and then August was very, very slow. And then right at the end, I think May just started podcasting, and it was actually the reason that I came up with the crazy station plots that we use. Was the September of 2011, the third week of September, we had 5 or 6 days of rain in a row in Tucson, and went from one of the driest summers on record to above average in about 5 days, right at the end of the season. And it got counted toward the monsoon total, and everything was fine. And I thought, this is insane. Like, you can't just catch up with all your monsoon rain at the end of the season. And that was the first time I had experienced that living in the Southwest. So that 2011, and it was a very similar pattern to what we saw this year, which was kind of caught in that transition pattern and approaching lows, drawing up tropical moisture, and then just parking and running days of rain over the same spots.
Yeah. Yep. I actually don't remember that. But I'm looking at the maps. The one, a feature, if we're thinking, broad scale here, a feature that is different is 2011 didn't show a wet signal for New Mexico. In fact, it
Yeah,
was,
it was different that way for sure. And this was kind of a little bit more of a local example, really reflecting my experience here in Arizona and especially in Tucson. We didn't actually have that same catch up type precipitation here this year, but it looked similar. In other parts of the state, Phoenix did. Phoenix caught up real quick. Parts of Phoenix did anyways in a very similar kind of pattern.
well, you brought up 2020. We've brought up 2020 before because 2020 is like the year that gives all of us, I don't know, nightmares and
Yeah.
other things, right?
Yep.
And I mean, this year was looking a lot like 2020 in terms of total precipitation. And then September actually like eh, you know gave us a little bit of a different story. But looking at the data, so Tucson Airport had 1.62 inches through August in 2020, and we had 1.99 through August 30th this year. So pretty close. The difference, of course, is that it didn't rain in September in 2020.
Yeah. Well, I would also argue that the 2020 analog was that more stations across the region were hanging together at very low totals. This year has been a bit of a mess because we've had a couple events here and there, much more activity than we've seen in 2020, and the Southwest has been bisected, where the real anomalies have occurred here in Arizona rather than like Albuquerque and El Paso over in New Mexico. So, 2020 was shared misery and just no moisture anywhere and no storms. But that's the crazy thing was, even as we were bumping along with our airport total here in Tucson, I could see it raining outside my window every day. It just wasn't raining at the airport.
Yeah, that's right. It reminded me, we used to talk a lot about spottiness, right? And
Yeah.
I tried to think about how can we actually characterize just how there are some years where the conditions, even though moisture is present, like the other conditions just favor like one or two cells popping off, but don't actually favor more organized systems developing. And that seems to be what we had a lot here this year. Like it wasn't as lacking in moisture around as it was in 2020, but it was also lacking some of the other conditions that were necessary for organizing that moisture. And we also, like, if I remember correctly, this year, and I don't remember this being in 2020, although it seems like it would be in 2020 just because there was a lot less moisture. And that is like the upper levels, like around 500 millibars, there was persistently dry conditions. So
Yeah.
even if you had lower level near the surface moisture, like, and that's part of the story, right? Like, yeah, there might have been moisture hanging around near the surface, but it couldn't actually get up to higher altitudes and coalesce and rain out like it otherwise might have if the upper levels weren't as dry.
Yeah. I think that's exactly what I was thinking about what made this year kind of weird was I think we talked about this a little bit last month. And again, Arizona and New Mexico have had really different seasons too. So we've got to kind of make that distinction. Is we have had it was humid for most of the summer. We didn't really have any big crashes. We had a couple of crashes in surface dew point temperatures, but overall, and if you compare it to like 2020, I think had seen more days kind of near average. But just like you said, is that shallow moisture was was parked at the surface, and there was really dry air above it, and that really had to do with the overall circulation pattern and the position of that mean low pressure system or mean trough off the west coast, which again, remember, is there's very dry air above the marine layer in the Pacific because it's cool air. And so that dry air is always trying to work its way inland. And when it works its way inland, it will mix out any of the moisture at the surface. And so whenever we did have the potential for precipitation, when we did have moisture that was a little bit increased at the surface, that would drive some instability. Those storms would pop up and they would pop up into a dry environment and they just get cannibalized by the dry air. And so you would end up, you could have wind events. The storms never got very organized. We had very few flash flooding events at any point during the summer. They were really isolated, and we didn't have any really widespread events. And I think that points back to we didn't see real deep Gulf surge events that you would see with the high in the right position. And the overall subtropical air mass was really pushed off to the south and to the east. And that's why New Mexico had done as well as it did, was that it was in deep all the time. We were in shallow moisture most of the time. And so whenever we would get storms, they would pop up in that dry environment. They'd be isolated and very, very spotty and scattered.
Well, when you said this, I mean, that all relates to the position of the high, right?
Yeah.
The fact
Yeah.
that we had that dry air aloft that would cannibalize whenever we did have moisture around, it's because the position of the high was further south, right?
Yeah. I mean, every day is a mess on a weather map, but climatologically, that's what we're talking on this podcast, is on average, if that Four Corners high is in Four Corners and we're deep easterly flow, that deep easterly flow is usually going to translate into good moisture at the surface and up through the lower levels of the atmosphere. So you're into the true subtropical air mass. We were always on the edge of it, and it was moving. It was almost oriented north south or maybe northeast southwest across into northern New Mexico and clipping down through southeast Arizona, and that moisture boundary would kind of move back and forth, and that was why the northern Arizona and northwestern Arizona, for the most part, were quite dry most of the summer because of that orientation of that moisture boundary. And it was only once we got into September, and I don't know if we want to transition into that conversation yet, it did shift around, and we did get into deeper tropical moisture as that trough retreated just a little bit off to the west and allowed a little deeper southerly flow, and the East Pacific woke up and started slinging tropical moisture up into Arizona in particular through September.
Yeah, let's get into that in 1 second. But I'm looking at 2024, last year and the year before, both bad monsoon seasons, by and large, across the Southwest, Arizona, New Mexico. I'm putting you a little bit on the spot here. I didn't ask you to think about this, but in terms of the position of the high, in terms of like the big synoptics, like, is there any similarities this year with those years?
Yeah,
Those
you're saying like last year? And
Yeah,
even,
last year, so 2024 or the year before that, 2023. So the last 2 years. Because both of them, like looking at the maps, both of them, I mean, Arizona looks very similar actually to 2023. The big difference is both of those years had pretty widespread dry conditions in New Mexico as well as Arizona, whereas this year it's more focused, the dry is more focused on Arizona.
I think the last two summers, if I'm remembering correctly, they were more that the Four Corners High was anchored over Arizona New Mexico border, or even a little bit further south over like the boot heel of New Mexico. So it wasn't as though there was a trough nudging the whole axis to the east. It was more that the whole ridge was suppressed to the south over the southwest. And in those situations, the southwest tends to hang together and go dry together if the high is kind of anchored between Arizona and New Mexico. But if it gets shoved off to the way off to the east and you get into more of a trough ridge pattern, which is really what happened in the spring, which caused the wet weather. unusual wet weather in May and June, but that it doesn't really work during the monsoon season. And once we got towards September, it turned more of a fall pattern that was accessing subtropical moisture that would be monsoonal typically in the middle of the season, and then started to make it rain again. So it's almost been it's like the same pattern we've seen for many months now, but it doesn't work the same way dynamically in creating precipitation as we move from one season to the next.
All right, so I routinely ask this question, and I routinely don't get good answers because I'm not sure there are answers. But going upstream, so the obvious question is why was that trough there?
I know it's a $10 million question, right? Is if you look at the hemispheric average pattern across the globe, there was a wave train, and we could count the wave numbers. I didn't actually do it, but they'll talk like wave index numbers and stuff like that. This was a fairly high wave index number that was a persistent train all the way across the Pacific, and you could see it show up in the anomalies all the way across North America as well. And so it was cool and wet over the Pacific Northwest, and unusually cool over Northern California because of that trough position. That led to a ridge shift off to the east, which then dried out and made it warm in other parts of the country. And we were left in between because we should be under a broad western scale ridge where we'd be under easterly flow underneath it.
Maybe explain what a wave train is for those that I mean, it's a meteorological term, right? Like I can visualize it.
Yeah, so when we talk about wave, we're talking about the position of high and low pressure systems, which translate into circulation around them in the different hemispheres. And we're typically thinking about this in terms of the middle parts of the atmosphere, 15, 20,000 feet. In our kind of weather climate parlance, it would be 500 millibars. We use that because it's kind of a nice, smooth level in the atmosphere that relates to things both above it and below it in meaningful ways. And you can have a wave train, and they're actually called Rossby waves. They're waves that occur on the horizontal plane. So you can look down on them from like a plan view and see the waves moving from north to south. And
Yeah, that's always the tricky thing.
it
Like
is, right?
on
Yeah.
a map, it looks like the waves are actually going north and south, but actually it's vertical. It's vertical.
Well, it's
Well,
so
they're both. They're both, right?
they're both
Yeah.
right. They're both. These Rossby waves are waves that are resulting from temperature imbalances from north to south, from the pole to the equator. And they're part of the dynamic way of moving energy around, through thermodynamic and mass fluxes. And they're part of a wind balance that emerges through pressure differences, right? The positions of highs and lows. And so they're waves. They're not waves like you think about in a swimming pool where they're moving up and down in relation to gravity. They're plan view looking down on a weather map, right? And it's really hard. But if you like, I still think about when I was growing up, we got cable in like the mid 80s, and we didn't get very many stations, but we got the Weather Channel. And so here's a 9-year-old kid, 9-year-old Mike Crimmins, watching the Weather Channel. You knew I was in trouble already. And they had an animated pulsing blue line that went up and down from north to south, and that was the jet stream. And so the jet stream is going to reflect that wave train all the way around the globe. And you can count the number of waves from north to south. And those waves can move forward, they can move backward, or they can stand still. And that's another kind of interesting feature about these kinds of waves. They drive storm tracks. And so we would watch those waves progress, retrograde, stand still in a blocking pattern, and they will drive surface weather through their position.
So what does the train refer to?
So a train is just a connection of
Okay.
dips and troughs, right? So
It's not it's not necessarily implying movement though, because they can be
yeah,
they quasi-stationary or like more
yeah,
persistently in one
they're
location.
yeah, and I
They can
think that
also be pretty progressive and moving.
yeah, the train part is the ridge and trough couplets, and they're connected together, I think. Dude, I'm totally making this up on the spot. Trying to dig back into my undergrad meteorological days and thinking of all those hours I watched the Weather Channel.
No, no, you did great. I don't I forgot even like the question that I that I asked. But I think like you brought up where I want to go, which is September, because we got to talk about September. And I have I have a lot of mixed feelings about September. It was, first of all, it's worth saying it was very noteworthy. We already kind of hinted at that. There were there were a couple rather large events depending on where you are. For example, late, I think it was around the 26th, Phoenix like tripled its rainfall in 1 or 2 days, right? So it went from, I don't know, it was like a half an inch to, it went from way below average. In fact, I have this. Okay, so at the end of August, Phoenix was coming in at had a half an inch of rain total between June 15th and August 31st, half an inch of total. That was the ninth driest on record. It ended with 2.76 inches, right? So 2.25 inches fell in September. And so it actually went from way below average to significantly above average. So, and there were two events. That was one event. And then there was another around mid-September, September 17th and 18th. That event, so going back, September 17th and 18th was fueled in part by a East Pacific tropical storm Mario, right? And when you look at the maps, it's kind of interesting. Like it's actually kind of hard to tell how much of an assist Mario provided. But what was clear is that after that event, there was a bunch of moisture that sort of just hung around for the rest of basically September. And then the latter event that I spoke about before, the big one in Phoenix, it sort of there was a low pressure system. I think it was what a cutoff low or a closed low,
Mhm.
and that sort of cannibalized, to use your word from before, drew into that all that moisture that was around and really set off quite a bit of activity. Is that more or less how you see it?
Yeah, there was a shift right around the third and fourth week of August where the precipitable water, which we've talked about before, it's a metric of water from this up through the top of the atmosphere. And it's effectively, if you were to squeeze all of it out, what's the depth of water you get in that column? And it's a metric because it's integrative, right? And we were suffering with pretty mediocre precipitable water for most of the summer because of that dry air above the surface, even if we had some surface moisture. It's just like you said, Zach, is that once the East Pacific got drawn in and it backed off the low or the trough off the west coast backed off a little bit, and but it was still helping to steer on the front side of that trough much deeper moisture, and that much deeper moisture actually sparked quite a bit of rain over like places like Yuma in September. And so Yuma actually jumped way ahead in total precipitation. It's very low bar for them to clear, but they easily cleared it as they started to get rain all the way up the Colorado River Valley, up into northwest Arizona. And the coup de grace storm of the whole season that pushed Phoenix to from way below to above average. And again, this is why it reminded me of 2011 because we did the exact same thing in Tucson that year. Was that approaching low with again all of that deep moisture? The approaching low, what it did that was really important for driving the severe weather event that occurred was deep moisture, but also dropping upper level temperatures. That's not, we're we struggle with upper level temperatures because we're under a ridge during the monsoon, and so you have to overcome those upper level warm temperatures have to be overcome by very, very deep moisture or high moisture at the surface to get convection. You can really lower the bar on that threshold by bringing in colder air aloft. We had both. We had good moisture, cold air, good upper level dynamics that you'd see in the fall. And that event produced heavy rain. It also produced numerous hail reports and wind damage across parts of the Phoenix metro area. And then it created some really, really disastrous flooding in Globe that killed several people. I don't know if you saw any of the videos of
Yeah.
Globe and Miami flooding into the evening hours of that storm event on a Friday night. It was insane. You know, it washed a whole car dealership inventory away, all these propane tanks. People were caught in their cars and swept away, and it was really devastating. And that community is still trying to recover to this day. And so, just a crazy way to end this monsoon.
Yeah, I was going to use the word, I was going to say that that event was sort of, or how you described September and like having moisture in place from, the East Pacific tropical storms, but also having a sort of fall-like pattern where
Exactly.
you can actually have cold conditions that affect the thermodynamic profile and also like create lift, right? Like those two things create like sort of an ideal September condition for widespread rain. But in the context of like what happened in Globe, like ideal is not the right word here because yeah, it's like produced uh catastrophic flooding. But just thinking about it from, a climate perspective or a perspective of generating rainfall, I mean that is kind of an ideal situation for rainfall.
Oh yeah, it's part of it's why we call them transition events. They usually occur they can occur at the beginning of the season transitioning if you're hanging on to any kind of spring pattern, which would be similar, and you have an active East Pacific that's got some tropical moisture that's going to sling it up. It's a little harder to do it at the beginning of the season because typically it's much, much hotter and that thermodynamic profile isn't as favorable. The days are much longer, it's much warmer through the atmosphere, and that deeper moisture is usually further away. It can happen kind of at the beginning of the season. But on the other end of the season, much more common is because you've usually spent the whole season in deeper moisture and the fall storms start to come out of the north. The days are much shorter, so it's accessing colder air to the north. Then you get these much steeper profiles. And the Cape values, that convective available potential energy, were bonkers for that event. And that's why, and the shear on the storms too, there was really strong shear from the lower level wind values to the higher levels in the storm, which allowed the storms to move quickly, to have real strong updrafts. And that's why you ended up seeing the hail, organized storms, and then the training of storms, meaning that storms are forming in similar, like it would rain and then a storm would pop up again an hour later and rain in that same spot and race off to the northeast.
Do you remember, I think it was 3 years ago, but that early October that felt like the monsoon, like,
Yeah, yeah, that's right.
and I'm betting that this was a similar scenario for that.
I know that's a really good question. So it just kept right. It was like the moon was was it even pretty good? And then it was October, and then we went into a wet winter too. I thought, remember?
Yeah, I think it was
Like
3 years. It was either 3 or 4 years ago. It was after a good monsoon season, if I remember correctly. But it was like,
Yeah,
yeah, I remember it being like, wow, the monsoon just isn't stopping. And so the point I was going to make is like, yeah, if there's moisture around, like we're in a season now, we're at the time of year when these low pressures can come in, and if there's moisture around, it can be producers. Um,
yeah, right. And that again, it's like it is all about the moisture down here. It's kind of dumb to say it, but it is really true. Typically, what happens this time of year is that the whole weather pattern becomes more zonal, meaning that you don't end up having strong ridge and troughs. You have a little bit more of a zonal, and it sinks south. And so as the high pressure sinks back into Mexico, kind of follows the sun south, you're usually the air to the north is much, much drier, right? And so those recurrent lows that come through, they scour out the moisture and they don't really have much to work with. So they don't actually produce much rain. And they gradually and persistently dry the whole atmosphere out. And then you just kind of move into fall. And then you've got to think about where that moisture comes from. But if you get stuck in the in between and you don't have those real strong reinforcing dry shots of air from the northwest, yeah, you can hang on in kind of a soupy pattern and get precipitation in October. It doesn't happen very often for us.
Or you get replenished by the tropical storms.
Tropical storms. That's right. Yeah, usually that shuts off pretty quick, but you know, you and I were just chatting, and this surprised me because I had totally like shut the door on thinking about weather stuff in the monsoon and just was going to go into normal mode for October, just expecting it to get nicer every day. And the East Pacific is pretty active over the next 2 weeks, with some of the forecasts suggesting that we will see the moisture plumes like we saw in September continue through the next couple of weeks in October.
All right, so we'll go there in a sec. There was in that latter event, the big one in Phoenix. It's funny looking at Phoenix's rainfall accumulative plot because it is just so overwhelmingly swamped by the rain on the 26th and the 27th. Anyway, I think there was Tropical Storm Narda at that time, but I
Yeah.
couldn't quite figure out if, like, just looking at the maps, like if that actually provided an assist too. It's really, I don't know if you know, and I mean, it was
I don't think,
present,
yeah.
it was part of the background conditions, but like the way that the wind vectors were, it was like, it seemed like that event was tapping more of like the remnant moisture that had just been sort of stuck around the area from Mario than actually like replenished by Narda.
Yeah, I don't think we actually had any kind of dynamical contribution from any of the storms. Lorena actually threw an assist up. No, was it? Yeah, it was Lorena. Lorena threw an
The
assist
one
up.
that was forecasted to come through the
Yes,
southwest has been
the
like
one
totally.
that we got pretty excited about, and the forecasts all they all fell apart. It was one of the weirdest things to watch was to watch those forecasts waffle right up until like a day or two before and just not get it right. And then the storm went like 180 degrees opposite of where the forecasts were pulling it. It was a tough spot for it. But that that moisture was still a reinforcing shot that did make it up into the southwest.
All right. So anything else you want to say about September before we move on?
No, I mean surprising.
Oh,
Very
there is something
surprising.
I want to bring up.
Yeah.
Maybe I shouldn't, but I'm gonna. I
Yeah.
know you hate this conversation. Um, but I guess I got like to the point where I got annoyed about September being part of the monsoon.
I know. I remember you excising it from the whole discussion.
Yeah, because all right, so I get it from the point of view of risk communication, where it makes a lot of sense to bracket the monsoon like we do, like June 15th to September 30th, like, right? It makes more sense to do that on the front end. And the back end is just arbitrarily chosen, right? Like the front end is chosen. I mean, they're both arbitrarily chosen, but the front end is chosen because basically the rainfall rarely begins before June 15th, right? Like it's the last of June and more into July, right? And but we don't really have a clear end point. And we didn't even when we had like the dew point definition, right? If you would have used the dew point definition for the end of the monsoon this year, we'd still be in the monsoon. Let's see if I can pull this up quickly. Um, yeah, we're still above average, but we're way below 55. We're at like, I think yesterday was at like 44. Anyway, like we were above 55 until September 27th in Tucson, right? So you can't even use that like dew point definition idea for the end of the month. Anyway, like I guess like I don't know how you feel about this, but I'm over September being the monsoon. I mean, it's more like it's its own thing, right? Like it is a combination of tropical storm moisture or moisture from the south and like these incursions of lows, right? Like that ideal condition. That's probably more the case for when you have widespread September rain than something that looks like monsoon. How do you
Yeah.
feel about that?
So actually it's interesting because I was really crabby about it, but as I was watching the messaging come out and reading some like the weather service discussions and the way that they talked about it as monsoon moisture made more sense to me. And I was like, yeah, that's kind of the right way to think about it because the season is about moisture. Like we can be real purists about the wind direction part of it, which is honestly what monsoon means. But by the time you get to the end of the season, you do end up having tropical moisture around that is related to the whole monsoon circulation, even if that circulation is subsided and is not really there and you're transitioning out of it. But, like looking at the dew point plot, it has a seasonality to it, and that seasonality does start to end really in the end of September. And it I think it'd be hard if we said monsoon season is over September 1st or September 15th, and every other year we ended up having events like this that occurred in the last 2 weeks of September and then didn't happen in October. So you'd end up like we need to call it a different season. I think that I'm a lumper now on this idea that I'd say throw it all in the same batch because it is monsoon moisture technically, different dynamics. The monsoon circulation is subsided. It always does. It always disappears beginning of September. And you have this opportunity for the tropical storms and the transition types events. But they're all, I think, kind of still related to the retreat of monsoon moisture to the south.
All right, I'm going to offer a different perspective.
All right, that's good. This is like
Like like
counter.
again, I get it for like the communication aspect of it, and it does make it simpler, which can be good. But analytically, like if we're trying to understand something about the monsoon, like we need to have a firmer understanding of what is monsoon, and we can't be lumping in rainfall because honestly, like often precipitation is a metric that's used, right?
Yeah,
We can't be lumping in precipitation that is generated from a decidedly different forcing than during let's say June and July and August, right? There is something like distinct about the way the atmosphere behaves in July and August than in much of September. And I just think like if we want to learn about how the monsoon is changing, for example, or trends and patterns and that sort of thing, and precipitation is a metric that we often use, then I mean it pollutes it, in other words.
yeah.
I
You're a
mean,
purist, dude.
well, I mean, I'm a purist I guess, in certain contexts, right? Like,
In
isn't,
this context, you are for
yeah,
sure.
like if we're trying to, like, can't we, isn't there a way, like, wouldn't it be better to track the position of the ridge? Like,
Yeah. It's so funny. We've been doing this podcast for 15 years now. We've done like, I don't know, 150 episodes. We've probably had this conversation 150 times.
I
I don't
hope
know.
we have new
It can't
listeners.
be 150 times. It'd be like once a year. So it'd be
I hope we
probably
have new listeners.
me too. No, but it's still like, but my thinking has really evolved on this is okay, fair enough. Like the rains of the last couple of weeks are like they're pumpkin spice flavored, right? They're fall rains, quite honestly. They're like a
That's what
mix.
I'm saying. They're fall rains. Like you even say it in your description.
I know, but the thing is that we I feel like there is no there is no pure rain event even in the middle of the monsoon season too. It's almost like we need to go event by event through the monsoon season. Because at the beginning, it's usually a mess. And then if we get into the middle of the monsoon and we have the ridge in the right place, is it been assisted by some kind of, you know, upper level trough, an inverted upper level trough, uh, or easterly wave, kind of like some kind of dynamic that's floated through? Is it just purely diurnal driven convection? Is it a mix of like troughiness off to the west and so vorticity matches maxes kind of floating up like we saw most of this summer? It's then the monsoon is really a collection of a bunch of kind of weird, very, unique weather events stacked up in the monsoon that create a total. And I kind of feel like the things that happen in September aren't that different than the weird stuff that happens in the middle of the monsoon. I'd say just throw it all
Oh,
together.
really? Really? Oh,
Yeah, I do.
well,
And
if that's true, that's a compelling.
it's a
That's
question,
compelling.
right? And
I
it's
mean,
the paper that I've been trying to lead us through for like 4 years now. We actually have a little bit of evidence that different things lead to different precip patterns through the season. And there's a collective total that comes at the end, but the makeup of all the pieces that go together to get to that total is kind of unique to each season. And there probably is some kind of average of like frequency of those, but I don't know. Is there a an ideal makeup of those kinds of patterns and events that lead to that total for parts of Arizona and New Mexico that are different?
so in my simple model, right? Like a difference is the presence of these low pressure systems from the west that are providing the dynamics that are able to draw into the moisture that's hanging around. That's like September, right? Like,
Yeah, this is a transition for sure.
yeah, like so what you were just saying as I was understanding it is those to me those low pressure systems, the frequency of them is much higher than what would happen in June, July, and August.
They can't happen in July and August for the
Exactly.
most part. Yeah,
Exactly.
yeah, yeah. Or,
Exactly.
I mean, could you I know. I'm trying to argue both sides here. Um, because I've in the past been pretty pouty about this too. Well, that's my like 2011 really kind of irritated me about the way we were thinking about the monsoon because I still remember, I think you and I were talking about this, that summer was not great. And then we got all the rain in Tucson in a couple of days right at the end of the season. And it turned out in the books to be slightly above average, where that did not tell the story of how the monsoon unfolded. And so, yeah, he's a hard nut to crack. I'm not sure
Well,
what
let me
that.
offer this because you said it before, and this is where I'm citing now. Is like I think we have to treat it as a distinct thing, and maybe it's part of the monsoon. Why don't we call it the after monsoon? September is the after monsoon. Like what? So, for example, in a lot of analyses, like if you think about like independent variables and dependent variables, right? Like precipitation is a dependent variable, and you're trying to explain that pattern.
Yeah, yeah,
So,
yeah.
so why not just use like to me, the monsoon is more encapsulated by just considering July and August.
So I would, if we're going to go that far, I would break it up into smaller parts, like three acts of a play, or periods or quarters, like we've tried to do before, because the expectation for how the atmosphere behaves in each of those, like say quarters or however you carve it up, is really different, right? The beginning, the patterns and the types of events you get at the beginning of the monsoon are different than the ones you should expect the first 2 weeks of August, that are different than the ones you expect at the end of September.
Ah, that's cool.
It'd
We
be
got
interesting, right? Yeah.
that.
Yeah, and each of those periods has its own climatological expectations, right? And then the frequencies. I think it's useful from a communications and a seasonal standpoint to look at those totals and map them out over time. But to your point, and I can't argue with that, is that total doesn't tell you anything about what happened during the season.
Exactly. That's kind of what I'm railing against.
Yeah, yeah. And I mean, this season,
I'm a little disappointed you didn't grab onto my after monsoon.
I,
September is it's like the after party.
it's not, I know, you were going for the after party, and I was just like, it did not roll off the tongue, the after monsoon. It like did not sound like, thumping music, flashing lights, like it didn't draw me in like that.
I'm
We
gonna
got
work
to,
on it.
I think,
I'm
yeah,
gonna
like
workshop it.
post monsoon raver, or like, I don't even know, like, I was started to get into whole like flavor, like what flavor of raindrops are they? Is it like some kind of easy
Pump,
swing at the beginning?
pumpkin spice, you
Well,
said.
pumpkin spice is the end. You work your way backwards. Is it just like a cold pour over in the middle of August, or
Oh, do it in coffee,
do it
right?
in
Like
I don't know,
you
like
got the
coffee?
espressos like July, like it pops off. You know,
Yeah, maybe that's yeah, yeah,
August is like no, August is the ice coffee. Like, yeah, we could take
yeah.
this in a lot of directions.
Like it's not going
Beer,
anywhere good.
we'll do beer next.
Okay, yeah, it sounds great.
Is it a IPA or a saison or a?
You get into Oktoberfest, whether you like it or not, in the end of September.
All right. On the horizon, where are we going? Right. So you sort of mentioned this a minute ago, like the short-term forecasts actually have some interesting activity in the East Pacific, no?
Yeah, yeah,
What do
yeah.
they look like? So this is probably not going to come out until Monday. Everything can change, so take that with a grain of salt.
That's the problem with even
Do they
having.
have them bending into the Southwest? I didn't
Well,
look.
I've been refreshing the forecast all day, and they've been changing all day.
Uh,
So I don't know. We can say is from a season, like a forecasting perspective, from the like a climatological perspective from the Climate Prediction Center, the Climate Prediction Center for the 8 to 14 day outlook. So they'll be out 2 weeks, and this will probably have a little bit of shelf life for it into next week, is suggesting that much of Arizona and parts of western New Mexico are not only leaning but likely to see above average precipitation for that middle week of second week of October. And their risk of heavy precipitation, they have a forecast, experimental forecast out. We're in a moderate risk for heavy precipitation, all of Arizona, parts of New Mexico. Um, that would be next weekend. So October 11th and the 13th. And that is
that's still
due
pretty far
to,
out. Yeah.
it's still pretty far out, but getting into these levels of, it's at least just sort of a situational awareness. My expectation would be that even if we don't see heavy rain, it does seem like we will see at least clouds and maybe some precipitation next week and through that second week of October. And then it's hard to say, the last 2 weeks of October, typically we'd start to see the East Pacific really quiet down, start to get the weather come in from the northwest, and we would typically dry out and cool down pretty quickly after that. But I don't know. This is kind of an interesting little twist here.
So that's funny. You brought something up that made me crack up because I was thinking about it all monsoon season, and that is like we may see some clouds, and that was like the best I could hope for this summer.
Wasn't it sad?
Like, I'm
Oh
not sure
my
it's going to
God.
rain, but we could have some clouds.
It's like the lowest bar possible.
Yeah.
When you're so crazy for needing rain out here, and you would settle for a cloudy day, we're in a bad spot.
So the longer term outlook, so we're heading into what looks like another La Nina event. So that would be like the fourth La Nina winter out of the last five, right? Yes.
Yeah, yeah.
So last year, actually, last winter, we were in an El Nino, and then the three previous winters we were in a La Nina, moderate to weak to moderate La Ninas. The seasonal forecast, I'm looking at the North American Multi-Model Ensemble. I mean, it basically picks up on that signal. So pretty dry in the southern tier, southwestern tier of the US for most of the models, with a wetter signal in the Pacific Northwest and British Columbia area. And there is some regional differences in the models, but that's more or less the picture. So Yeah, we'll have to wait and see on that. I mean, we talk about this on many of our listeners probably are well aware that the La Nina signal tends to be more certain, more certainly dry than the El Nino signal is certainly wet. Um, I don't know if there's a better way to say that.
Yeah,
I have
right.
higher confidence that it'll be dry than if it was
Yeah, it's just
El
easier to
Nino.
go dry here. Yeah,
There's another complicating factor, Mike. I don't know if we want to spend time about this, but talking about this, but the North Pacific is warm. So people have labeled this the blob, right? Like a big area of warm weather and sorry, warm sea surface temperatures that form in part because of in the past, like months going in the back in the past, there's been a high pressure system there that has basically limited winds, limiting mixing in the ocean that allows surface water to heat up and to stay in place, right? And so they've termed this the blob. And like I don't know if you remember, like what was it? Almost like a decade ago now, like the last
yeah,
super El Nino, there was all this chatter about, well, will the La Nina, or sorry, will the El Nino, will its signal override the sort of warm tropical or warm North Pacific waters, right? Because they can have, I guess, opposite signals in terms of rainfall in the along the coast of. I don't know. Is there anything you want to say about that? Do you have anything to say about that? That's the other. It made news. Let's say people are starting to talk.
yeah,
It
yeah.
could
I
be a
don't think it's.
complicating factor for this winter, or
Yeah,
not.
I always get a little bit. I don't know if confused or I get thrown off by real strong connections or forecasts related to North Pacific sea surface temperatures. Because so what I learned in school was that the sea surface temperatures along the equator have direct atmospheric coupling. Like when they change, they modulate the weather above it through convection. So that's why you get, Walker circulations and it's related to Hadley cell circulations and those kinds of things. So changing those temperature gradients and popping areas above certain threshold temperatures can increase convection above it. So when you get into mid latitude ocean areas, the sea surface temperature modulation is and the coupling is usually much weaker, and the sea surface temperatures are usually reflecting what the weather pattern has been above them rather than driving the weather pattern themselves. You can have this is where I do not have a lot of knowledge and expertise, but the changes in the sea surface temperatures of a couple of degrees, like in the mid latitudes and the northern parts of the oceans, can change the evaporation rates and salinity and those kinds of elements, which can influence overriding weather patterns, but it's just a lot weaker. And so I do think that the blob is emerging because of persistent weather pattern that we've seen over seasons to maybe years now. And it is emerging. The last time it happened was like 2013 to 2015, kind of prior to having that big El Nino event that emerged in the Western Pacific. That's not a forecast, but it's just sort of an interesting thing is that we've run into a couple of seasons of La Nina. I would expect that the teleconnection with the Southwest is probably it's a weak La Nina. It's probably going to be short. It still will probably tilt us towards below average precipitation. Don't really know what the blob says about that, other than maybe it's a precursor if that weather pattern's persistent of ridging over the North Pacific that could lean into the Western US, which would also contribute to our dryness. I'm kind of more interested now of like thinking about what happens after this La Nina winter, and the West Pacific must be pretty recharged now and have quite a bit of warm water. And I would expect that we would see an El Nino event in the next couple of years, and maybe it could even be a big one.
Just because we've had four of the last five that have been,
Yeah,
is that what you mean? Because we
yeah,
had one, I mean, it was not with, I mean, last winter it did sort of reach moderate to moderately strong strength.
La Nina.
Oh, La Nina. No, El Nino. I thought you said that you would, looking forward, you'd expect, you're expecting like, did I mishear you?
No, no, I would expect with a run of a couple of La Nina winters that we would see an El Nino
Yeah,
pop up.
yeah. And I heard
Yeah,
you right. But
yeah.
I was saying like, I was interpreting that as like this sort of boomerang. I mean, it's not really what's going on, but like sort of a boomerang. And last year we did actually have a pretty strong, moderate to moderately strong El Nino event.
Last winter?
Yeah.
Am I thinking of this wrong? Maybe, maybe I'm
So
going.
I have the data right now. So 20, okay, so in the
Oh yeah, 23, 24. So it
so
wasn't.
the 2024 last December was the anomaly was 2 degrees Celsius in the in G November, December, January period for 2024.
It was
Wait, wait a
last
second.
fall.
I'm reading this wrong.
Okay.
You are correct. That was, oh man, it's an illusion. It was 2023.
Yeah, 2023. I remember it was a couple of winters ago, and it did have a decent teleconnection. It was okay-ish.
Oh man, I screwed this all up.
No, no, I got you. Yeah, it's you're right. That was a big release. That was I thinking of one of the conceptualizations of El Nino is this recharge discharge cycle that occurs across the Pacific, and that was a pretty good discharge. So maybe we are looking at a couple years of this um, La Nina recharge. The other thing too is that the relative El Nino index, which is coming out of CPC, which is trying to account for increasing sea surface temperatures all over the globe with climate change, is making this kind of like figuring out what's going on harder
Yeah.
on and with the background state changing.
All right. So put a pin in that for 1 second. I want to clean this up a little bit. All right. So last winter, we actually did not have a La Nina event. We had an ENSO neutral event
It was
that
neutral. Yeah, it was borderline.
it was
Yeah,
borderline, right?
yeah,
It didn't
yeah.
meet the threshold, but it was a negative anomaly. It just didn't meet the threshold. The
That's
year
right.
before that, so um, let's say November, December of 2024, and then January of 2025, right? Wait, I'm screwing this up again. No, November, December November and December of 2023 and January of 2024 was a moderate to moderately strong El Nino.
Yes.
The year before that, the year before that, and the year before that, we had three back to back to back La Nina events.
Thank you. That's what I'm seeing too. Is that, yeah, we had triple dip La Nina followed by strong El Nino. Last year was neutral. We had a little bit of a flavor of a La Nina, and right now it looks like another kind of probably neutral to weak La Nina. So yeah, maybe it does look like that we are a couple years off
Yeah.
of an El Nino. So there's that
And
for
they do,
you.
yeah, they do.
Useless.
That was more difficult than it needed to be.
I hope,
Um,
hopefully everybody's dropped off by now and isn't
yeah,
confused by that conversation.
they do have probabilities fairly high for an emerging La Nina event.
Yeah,
Um,
it looks to be short and probably pretty weak, but nonetheless probably will impact us on the dry side.
um, anything else?
We're just going to make a mess of it if we talk about anything else.
Well, I guess I'll just say this, right? Like we had a pretty bad last winter in terms of rainfall.
Yeah, it was very bad.
We've had bad monsoon seasons. And if we had another winter on top of that of widespread dry conditions, again, like all of the sort of dry side hazards ramp up. The water issue ramps up, the fire risk ramps up. Obviously, drought will expand. So, I mean, we always talk about this, like it's having back to back, just two in a row of dry precip seasons is stressful, and this might actually be four, right?
Yeah.
So
Yeah.
2 winters ago, the El Nino winter, do you remember what that was? Was that
Uh,
it? I,
2023, 24, I think it may have been more average-ish.
yeah. So at least we had a poor monsoon, a bad winter, followed by another poor monsoon, and now we're at whatever this winter will look like in it. And if we had to make bets right now, it would call for a sort of at best, an average, but more likely a below average winter rainfall season, winter rain precipitation season. At least for Arizona. Again, like everything sort of like none of the ENSO signals really apply to the upper Colorado River Basin where the snow falls. So we always have to make that note.
Yeah. Yeah. We stringing together multiple seasons where you expect precip it has caused problems. The ranching community is really suffering. I know in Arizona, a lot of ranchers are going out of business because of no water and no forage. And the weird thing is we had precip in June in some areas, like some flash flooding across northwest Arizona, and then you get all this precip at the end of the season. It goes into the total, but the ecosystems aren't really set up to use precip when it's really off timed like this. And if it's not a ton, it doesn't actually really impact the water resources side of it. So it's almost like it's a little bit of a distraction rather than a help.
Mm. All right, Mike, thanks so much again. Any final parting shots?
No, let's move on to fall.
All right.
It's
I'm excited. I'm
Me
excited
too.
for October. All right. Well, thanks everybody. Thanks to our producer Stacy and all of you for hopefully staying with us this long. If thank you for staying with us for whatever time you've given us. We'll come back in about a month.
Happy fall, everybody.
All right.